Heyo, it's me, Miss Billman. We're going to look at adding and subtracting fractions. I actually have two examples that I'm going to show you of adding and subtracting. Some of them might be familiar of the two. So when we're looking at adding and subtracting fractions, this video is going to be specific to focusing on the fraction part, not the whole number. So if you were hoping I was going to do some improper fractions, sorry friends, I'm not going to do it. But hey, look, I'm totally going to try and use as many things on here as I can because it seems kind of fun. So we need to start with a problem, right? So let's do 1 and 2/9, and we're going to add 3 and 1/2. That seems straightforward. Like I said, I'm only going to focus on the fraction part, but you are a powerful mathematician on a mission when you can solve using multiple strategies, like turning it into an improper fraction. I like to have both of those in my back pocket or my mental toolbox to bring out whenever I need it. When I check an answer, if I want to check it again, I like to use a different strategy just to see, hey, did I end up with the same? So we're going to focus on the fraction first. So that 2/9 and that 1/2. I need to find a common denominator, right? So 2/9, oh, ugly 9. I better erase that and try it again. I'm going to rewrite the 9. So 2/9, there we go. 2/9 and 1/2. So I need to find a common denominator. I'm going to start listing them off. 9, 18, 27, 36. Now I know because I have a 2, I'm going to have a denominator that is an even number. So it's going to have to end in a 2, 4, 6, or an 8. So I go ahead. I know 27 can't be it. Could be 18. I think that might be my least common multiple, and that will be my common denominator. All of these vocab words, they run together, and I'm going to try and make sure I use them as much as possible to ingrain them in my brain. So 18 is my least common multiple, and so it's my common denominator. Now, what did I do to the 9 to get to 18? Well, I multiplied by 2. Now, I don't know why I have 2 multiplies, but that's okay. I still multiply by 2. So when I do that to the denominator, I need to do it to the numerator. 2 multiplied by 2 is 4. Now to 1/2. I multiply by 9 to go from 2 to 18, and 1 multiplied by 9 is 9. Time to rewrite it. I'm going to rewrite it with these new equivalent fractions. We talk a lot about equivalent fractions, and that's what we do when we are using the least common multiple to find equivalents. They're equivalent. So I rewrite it as 1 and 4/18, and I add 3 and 9/18. The cool part is, now that I have a common denominator, I can add straight across. I don't need to worry about, what am I going to do? I'm going to add the 1 and the 3. I get 4. And 4 plus 9 is 13. And my denominator stays the same. And it's 4 and 13/18. Pretty straightforward, right? And again, the more you practice, the better you're going to feel, and the more confident you're going to feel when it comes to things like this. So let's look at subtraction. This time we're going to have 5 and 2/7. We're going to subtract 2 and 4/5. Now this one is going to be a little bit tricky, so hang on to your hats because it's going to be intense. Again, I am going to focus directly on the fractions first. I just feel more comfortable with that. And I don't want this to be, like a half an hour long video. That just sounds terrible. So I'm going to focus on the fractions, and I will be circling the 2/7 and the 4/5. So my 2/7 comes on down, my 4/5 comes on down, and I need to find the multiples of this that go together. Now, I do know I can multiply the 7 and the 5 together and get 35, which, if I was a betting woman, I would guess that might be my least common multiple. But let's go ahead and find out. So 7, 14, 21, 28, 35, 42, 49, And with 5, I know it's going to have a 5 or a 0 at the end. So 5, 10, 15, 20, 25, 30, 35. Winner, winner, chicken dinner for 35 as my least common multiple, making it my ding, ding, ding denominator. So 35 is my denominator. I circle it, and here I go. What did I do to the 7 to get to the 35? I multiplied by, yep, it is by 5. Now for the 5, I multiplied by 7. And remember, what I'm doing to the denominator, I need to do to the numerator. So 7 multiplied by 5 equals 35. 2 multiplied by 5 equals 10. 5 multiplied by 7 is 35. 7 multiplied by 4 is 28. So I can rewrite this as 5 and 10/35 minus 2 and 28/35. But now I have like a head scratcher. Now I have my equation, have equivalent fractions, got the common denominators that are made from the least common multiple. I followed all the directions, but what just happened? Right? I have 5 and 10/35, and I have to subtract 2 and 28/35. I can't have negatives. What? Oh, okay. Now I need to bring in some strategy that I have. Now it's going to be a new page, so again, hold on. But now I need to do some minor regrouping. This may be familiar to you. Now, when we regroup, we need to make sure we have the problem written. Now you see I'm going to go back to the page and make sure I write it correctly. I already know it's 5 with 10/35, and we subtracted 2 and 28/35. Go back to my other slide and write it down. When I have a fraction, especially with a whole number, that's like saying 5 completely whole. In my mind are pizzas with 35 slices each. It's similar to when we borrow when we do subtraction, right? If I needed to borrow from the tens, if I borrowed 1 from the 10, it's like saying I had 1 10 and now I have 11 ones. It still equals $21, but it's a little bit different. But this whole number of 5 is like saying 5 in 35 sliced pizzas, entire pieces, right? These pizzas that I have. So I can borrow from them. Now I can borrow a whole, and I'm going to add that whole to my numerator. It's just like saying 2 $10 bills and 1 $1 bill. That's $21. But I can borrow and have 1 $10 bill and 11 $1 bills and have $21. So I borrow from the 5 and it becomes a 4. But when I look at these wholes, I like WHOLES, I actually have 35, so I'm adding 35. So my 5 becomes a 4. I add a whole 35 sliced pizza to my numerator, and I have 45 over 35. And I'm going to subtract 2 with 28/35. Now I'm able to subtract. How amazing is this? Now, these are equivalent. They look weird, right? Because it's like, well, 5 and 10/35 and 4 and 45/35. They are still equivalent. Yes, this is totally like, I'm getting goosebumps from all this math happening. So, it's time to subtract. 4 and 45/35. And I'm going to subtract 2 and 28/35. I already know I can subtract my whole numbers. 4 minus 2 is 2, but I'm going to actually pull my 45 and my 28 up above to do some subtraction. So 45 minus 28, I gotta borrow, and it becomes 15 minus 8, which is 7, and 3 minus 2, which is 1. So it's 2 and 17/35. Boom, mic drop. Yes, feeling awesome. We did that, you guys. We got this.